Hi there, hope you have a fantastic day today. This lesson I'm going to teach you prime and composite numbers. By the end of this lesson, you should be able to identify prime and composite numbers. So let's go straight into it. A prime number is the number that has only two factors. In another word, a prime number is a number that can only divisible by 1 and itself. So the smallest prime numbers is 2. And don't forget, 1 is not a prime number because 1 has only one factor. So that is 1. So therefore, 1 is not a prime number, okay? So 1 is a square number instead. So the next prime numbers after 2 is 3. And the next one is 5. Not 4, okay? Because 4 has more than two factors. The factor of 4s are 1, 2, and 4. So have 3 factors. So therefore, it's not a prime number. So the next one, not 6, because 6 can divide by 2 or 3, right? So the next one should be 7. And after 7 is not 9, because 9 is divisible by 3. So therefore, the prime numbers that after 7 is 11. That is correct. And followed by 13. Because 13 cannot divide by any number except 1 and itself. And the next one is 15. No, 15 is divisible by 5 or 3, right? So the prime number that is after 13 is 17. And after 17 will be 19. So these are the prime numbers that less than 20. Please pause the video and write down the numbers that are prime between 20 and 30. Right, let's go through it together. So the prime numbers that after 19 will be 23. Because 21 is not a prime number because 21 is divisible by 3 or 7, right? So after 23, it should be 29 because 24 is not a prime. 25 is not a prime because it's divisible by 5. 26 is even numbers, not a prime because it's divisible by 2. And 27 divisible by 3 or 9. 28 is even number, so it can divide by 2 or 4 and 7. So 29 is the prime number that is just below 30. So I hope you got it correct. So next one. Please pause the video and write down the prime numbers that are between 30 and 50. Right, how do you go? So let's go through it together, okay? So the first prime number that after 30, it should be 31. And the next number after 31 is not 33 because 33 is divisible by 3 or 11, right? So the next one should be 37 because 35 is divisible by 5, right? And the one after 37 is not 39 because 39, if you add these two digits together, is actually 12. So therefore, it's divisible by 3. So therefore, it's not a prime number. So after 37 will be 41. Now after 41, it should be 43. Now after 43, it should be 47. Because 44 is not a prime, 45 is not a prime, 46 is not a prime because 46 is even anyway, and 47 is a prime because 47 cannot divide by any other number except 1 and itself. In another word, 47 has two factors only, 1 and 47. And that's it. 47. Because 47 has only two factors. 1 and itself. I hope you got it correct. A composite number is the number that has more than two factors. In another word, a composite number is a number that can divide by another number. So therefore, a composite number has at least 3 factors. So for example, the first smallest composite number is 4. Because 4 can divide by 2. So 4 has 3 factors, in fact. 1, 2, 4. So 3 factors. The next composite number that after 4 is 6. And after 6 will be 8. And 9. 10. Not 11, because 11 is a prime number. So 12. After 12 will be 15. And 16. And 18, not 19, okay? So these are the composite numbers that are less than 20. So please pause the video. I want you to list out the composite numbers that between 20 and 40, inclusive, okay? Inclusive means including 20 and 40. Right, how did you go? So let's go through it together, okay? So the first composite number that including 20 to 40 is 20. Followed by 21. Because 21 is divisible by 3. After 21 will be 24. Because not 23, because 23 is a prime number. 23 cannot divide by any number except 1 and itself. And after 24, will be 25 and followed by 26 because 26 is an even number, so therefore it divisible by 2, and followed by 27 because 27 is divisible by 3 or 9, and followed by 28 and not 29 because 29 is a prime number. So the next one is 30 and not 31 because 31 is a prime number, right? And then 32 followed by 33 because 33 is divisible by 3 or 11. And after that 34, 35 because 35 is divisible by 5 or 7. And 36 because 36 divided by 2, 4, 9, 6 and 12 and so on. And then 38 because 37 is a prime number, followed by 39 because 39 is divisible by 3, and followed by 40, that is inclusive, that means including 40. So here's the question: what is the largest 2 digits number that is prime? So please pause the video and try it yourself. Right, how do you go? So let's go through it together, okay? See how you go. So the largest 2-digit number, we start from the largest, yeah? So you might have different techniques, but the way to do this is I start from the largest 2-digit numbers. And if it doesn't work, I go down, okay? It's quicker, that's all. So the largest 2-digit numbers is 99, because that's the largest 2-digit number. But then 99 is divisible by 9, 11 or 3, right? So therefore it's not a prime number. Then the one smaller than 99 is 98. But then 98 is an even number. Please take note, the only even prime number is 2, okay? So every prime number is odd except 2. But not all the odd are prime, okay? Please take note on this. So keep that in mind. So 98 is not a prime. And the next one, 97. Now 97 is possible, is a prime number, but we have to test it. So we know that it's not divisible by 2 because it's odd. And if we add 9 plus 7, so I just write here 9 plus 7, which give me 16. So it's not divisible by 3 and not divisible by 9, right? So not 3, and we know that cannot divide by an even number because it's odd number. Remember that for me. So this is 5, not divisible by 5 because have to end with 0 or 5 in order to divisible by 5. So therefore not 6 and possible 7. So we have to try 7. Now there is no easy way to work it out. So therefore we just do a quick division. Okay. So 97 divided by 7. 7 go to 9 is 1s, remainder 2. And 27 cannot divide by 7 because there will be a remainder. So therefore is not divisible by 7. And 8 is definitely not. 9 is definitely not. We already work it out. And not 10, of course. Remember, divisible by 10 must be end with 0. Okay, the number. And then 11 is not divisible by 11. Remember, now in order to divisible by 11, the sum of odd digit and minus the sum of the even digit. And if it equal to 0 or multiple of 11, then it's divisible by 11. But then 9 is the odd digit and even is the odd digit in position. Okay, remember that. So now the odd digit is 9 and the even digit is 7. So 9 minus 7 is 2. So therefore it's not divisible by 11. And it's not divisible by 12 either because 12 is even number. So we stop there because 12 times 9 is greater than 97 anyway. So we test all the number already. So therefore it's not divisible by any of the number. So therefore 97 is the largest 2 digits prime number. What is the smallest 3 digit number that is prime? Please pause the video and try it yourself. Hi, I'm back. So how do you go? Because the question is asking for the smallest prime number, right? For 3 digits, of course. So we're gonna start from the smallest 3 digit number. Okay, and we go up. So the smallest 3 digit number is 100. Because that is the smallest 3 digit number. Then it's not a prime because it is a composite number because 100 is even number. So it can divide by 2, can divide by 10, divide by 5 and so on, right? So therefore it's not a prime. So we just cross this out. And the next number is 101. But then is 101 is a prime? Well, it's possible, right? Because we know that is not divisible by 2 and not divisible by 3 because 1 plus 1 is 2. Or I just write it down, 1 plus 0 plus 1, which is 2. So it's not divisible by 3. Of course, not divisible by 4 because 101 is an odd number. And not divisible by 5 because must end with 0 or 5 in order to divisible by 5, right? And not divisible by 6. And is it divisible by 7? So there is no easy way to work it out. So we just do a long division or short division, whatever you like. So 101 divided by 7. So 7 go to 10 is 1s, remainder 3. So that becomes 31. And it's not divisible by 7. So we just write this down. And then 8 and not divisible by 9 because we already worked that out. Because 1 plus 1 is 2. So not divisible by 9. And not divisible by 10. And is it divisible by 11? Well, let's work it out. So in order to divisible by 11, the sum of the odd digits minus the sum of the even digit. Now, if it equal to 0 or multiple of 11, then divisible by 11, right? So this is first, second, and third. So 1 plus 1 equal 2, and 0, we just write it down. So therefore, the difference is 2. So therefore, not divisible by 11. And then what about 12? Definitely not divisible by 12. And we can stop there because 12 times 9 is greater than 101. So therefore, we can stop there because any of these number is not a factor of 101. So therefore, 101 is the smallest 3 digits number. That is prime. Thank you so much for watching. Bye.